To Introduction to Computer Graphics. This is the lecture on textures. It's very nice to have at least 2 listeners live here. The rest will definitely watch the video offline because I am really into asking these crazy questions about it. And then only then you can score the 5 points. Anyway, if you're interested in your current standing, hi. And if you're interested in your current standing, please check the Moodle page where you can find your current score. Yes, and now we're going for textures, and this is black roll ball for facial training, which totally looks like an orange but has more texture. So this is my example. I also would have a grapefruit here, but not as good as the ball. And the idea would be how to get the model, which is actually here, more realistic, like here. And the color and shape is not enough. So we discussed the shape mostly with the polygons, and the shading was also part of it, which gives color and gradients, dark part or a light up part. But we need a little bit more than that to actually be able to do something like that. Yeah, that would be really cool. So we can add a rough surface with small notches. And then it would maybe look a little bit like that. Now with the lighting, it looks crazy. Also, you can see there is some problem. We could model these notches, but there are so many triangles, and that's actually the problem. How to get more realistic without actually modeling reality too much detail. And that's what we're going for with textures. So the key idea is, instead of modeling the material and geometry perfectly, for each point on the surface of the model, we define a function. And with this function, we can actually give a certain point a certain color. We can also give them a roughness or a specular component. We can define the reflectiveness, the opacity, or even the displacement of the point from the surface. That's the cool part. So instead of having X and Y, like we have in 3D coordinates, to not mess them up, we're using U and V, whereas U stands for the X and E stands for the Y, but they denote points on the surface or points within a texture and not points within 3D. So that's why they're called UV. So we would have something like that. We would have a cube, and on the cube there is an image, and we can actually look it up. So for the point on the cube, we look it up in the image with the function, and we see, oh, okay, it's the broadcasting tower. It's here. So we put it there. And we have an image in 3D. That's the basic idea. One thing that is very important is to actually define this function. So where do we look up the UV on the model surface in the UV in the texture? And that process is called texture mapping. So it's actually like wrapping a present. You have a flat thingy, like the paper, to wrap your present in. And you have a 3D mesh, like your present. In the best case, is a shoebox, then it's easy. In the worst case, it's something with a lot of crevices and notches and a very complex shape. And that also is what the mapping is about. The more complex the shape, the more complex the mapping is. There are different basic techniques for projection, and this would be just one example for a 6-sided die. So we say that this is one side, we say that this is one side, this is one side, and so on. And just to be clear on that, anybody knows if there are any restrictions on a die or on dice? Now, I mean, the wisdom of the crowd is definitely limited. Wait, I can check. Yeah, I know it. I asked the other 2. I'll solve the riddle. The sides that are opposite to each other on a 6-sided die sum up to 7. It would be 6, on the other side would be 1. On side 2, on the other 5, on side 4, on the other 3. Strain for a 6-sided die. Otherwise, you're not allowed to play with that die in the casino. Yeah. Of course, it can be more complex than just a few points on turquoise surface. So for instance, we can use the Earth image from NASA. So there's obviously a satellite that can look around the corner. You take a lot of images and stitch them together. That's the whole idea. And then you can get the Earth image from NASA. You can find the link to the Earth image in a lot of different resolutions in the slide notes. So they're down below. And I actually prepared. I did start Blender earlier. I prepared it in Blender so that you can see. So that would be 3D surface. A lot of points. Okay, yeah, that's related to my question before. I had a problem while doing the homework. I found dice with different placements of the numbers and didn't know if there was a difference. Yeah, it doesn't matter. For our homework, it doesn't matter. It was just an anecdote that not every dice is a regular die. Not every die is a regular die. That's the whole idea. So the opposites should sum up to all the same thing. All the opposite sides still added up to 7. That's great. Yeah, so then it's basically the regular 6-sided die. Okay, so that would be the model. Without the texture, it would look like that. We can shade it smooth or flat. And then we can just add the texture. This might take some time. And here's the texture. Shade smooth. And now we actually have a very nice picture of the Earth. The more, of course, we zoom in, the more we see that the texture quality is not perfect. So we'll have JPEG compression artifacts and everything. But yeah, we can use a bigger texture. This is just a 2 megapixel texture. There are bigger ones, but of course, they're straining the graphics card. Oh, just smaller. If I close it, the next time I'll open it, it will recompile all the shaders again, and we have to wait. Yeah, so there are standard mappings, and of course with a sphere, with a cube, with a cylinder, with a cone, it's all basically mapped out. So in P5.js, you don't have to worry about that. Also, the same thing goes for Blender and game engines. There, you can sometimes switch them from planar to cylindrical to spherical mappings, and as you can see, there might be a problem with the mapping here, planar mode, or here in cylindrical mode. And the right one is, of course, the spherical mapping for a sphere. That's where the name comes from. So what we do with manual UV mapping or texture mapping, we define how the surface model, the model surface maps to the actual texture. And we can define this per point. And here we can actually say this point maps to this point in the image. This point maps to this point in the image, and this point maps to this point in the image. If we add this point to this point, then we know all those points that are on the surface between those 4 can be interpolated. So that's the beauty of it. The downside is, of course, with image textures, that the lower the resolution of a texture actually is, the more limited the view, of course. The view quality is then worse. So if we zoom in, we can see that it's not a perfect circle, but it has some artifacts from the underlying pixel. In this case, it's based on the texture filtering. I don't know what your computer science background is, but you can have a nearest neighbor filtering, which would then result in blockiness. This most likely is linear filtering or bilinear filtering, where the points only are resembled in the center of the pixel and the rest is blurred out a little bit to not have this effect of that's basically a little bit like aliasing a little bit the last time. Anyway, this is not the digital signal processing lecture, just that the filtering depends on how you perceive the textures if you zoom in too far. Repeating textures, of course, sometimes, or actually very often, the texture is smaller than the actual object. And then you can repeat it. For instance, if you have a square, what I'm talking. Yeah, maybe I fix it. If you have a square texture and you have a die with 6 sides, then you can put it on each of the sides. If you take a close look here, you see that there is a notch in the texture. There's the notch here in the same texture. There's the notch here in the same texture. There's the notch here in this one. This is actually a pretty cool example because I can show it. But how did I do it? There is a mobile application from Adobe. I don't know if it's still here. And then you can take a picture of something and it creates a texture image out of it. That means that the image has the same lighting, the vignette from the photo is taken away, and they make it repeatable so that you don't see easily that it ends here and then ends here, and if you stitch them together, that they can still work out together. So that's the beauty of texture. Here, the texture is repeated 5 times per side. Of course, zoomed out so far, you don't see the texture anymore. This is actually a piece of cloth. Not recognizable anymore. You can have different texture repeat strategies. You can wrap them, tile them, repeat them. That'd be like this one. Then you have to make sure that when the texture starts on the left, it should resemble, or it should start glitchless with the end of the right side of the texture. That's the whole idea. That's very hard to do. There are a lot of tutorials, a lot of software for that. You can also mirror it. That would be this one. This would take away the problem of the non-matching borders. But of course, it has other problems. And then you can clamp it so that you can basically just repeat the last. I have no practical application of clamping. Then you also have procedural textures where you use functions instead of images. And typical functions are random noise, Poly noise, Wally noise, and so on and so on. You can have sinus waves and whatnot. Maybe I left it open, I can show you. So if I click here. Oh no, that's the volume. That's what I wanted. I have to up a little bit here. Yeah, move it here and then give you the full size image, main screen solo. Okay, so this would be the shading part, and what we really want to do now is we want to change this one to procedural texture. So I remove this one and other texture for wave texture, for instance. We'll go through that in the Blender thingy, so that's not the problem. But what I wanted to show you is that I zoom in and the quality is pretty good, so it's not pixeling out in any way. And then I can create stuff like marble-like thingy, detail here, and then we would have something that is quite well defined on every level. And then you typically just add up with that. For instance, we can have converter and do color ramp here. So in output this one, and it doesn't change a thing. Wait, same, yes, but we can do something like that. This, of course, why not? And then we already have a very different texture. So we remove the gradients. Like that. And yeah, there are a lot of things you can do. You can put them all together and so on and so on. So I'll leave that for now. Switching back to the slides. Still do that. So that would be just zoom in a Voronoi texture, Voronoi procedural texture. Voronoi procedural as far as I. But anyway, I changed the slides. If you want to know more about procedural textures, then of course take a look at advanced topics in computer graphics. I do that. Yeah. These image textures define a color of a pixel through UV mapping. And what we can also do is we can carry any numeric information and which we can use in any other way. We just have to tell the rendering pipeline what it should do. If we have 3 dimensions, we can interpret it as red, green, blue. If we have 4 dimensions, we can interpret it as red, green, blue, and alpha, which would be the transparency. We just have one channel. We can say it's the transparency. We can say it's the it's the gray value, we can say it's the green value, we can say whatever we want. And what we can also say is that instead of just saying this is black and this is white, we can say the white one is actually on the level of the plane, while the black one is sticking out, and everything in between is in between. And that's what they call bump maps. That's also pretty cool. So instead of having the image put in as a color, we can say it's a bump map, and then we can have it stand out or not. We can have soft or sharp edges. Bump maps can then be a little bit blurred out, like here, or very sharp, like a laser cutout from a alloy cube or something like that. And what they actually do, bump maps don't change the point, but they change the shading. And if you remember correctly about shading, it's all about the normal vector. So what they do is they change the normal vector. And we can actually have some fun in Blender to take a look at that. Let's see. Oh, no, I didn't map it. So now what we can do actually is, instead of putting this into the color, we can have a bump map here and put in the height. So what we have is a color. Let's map the color here. We don't say it's a color, but it's the height. I'll just a little bit to see more. Give it a distortion to have more crevices and a little bit of the detail. Okay. And then we say this one is our height. And then we get a normal out of that. And the normal vector we put in here. And then we wait a little bit, and you see there's ups and downs. And then we can say we want to have less strength, so less up and downs. We want to invert it. Take some time. And we want to have more or less distance. Nice one. And that's completely independent of the color, so we can still have the color here. Would then make it extremely awesome. Awkward. Yeah. But so typically you just mention this color. Have something going on. Rough, then you have the specs here. So that's actually the part of it. Invert it better. The stream kind of broke for me when you connected the normal. Oh, I'm sorry. Does it work again? So it does not say that the stream is not working. It's sending with 10 megabits. Oh, yeah, if something like that happens, I do a local recording and I'll edit the recording and put it up so you can rewatch it. And actually we redo, thank you very much. We'll redo it anyway in the Blender thingy. Yeah, so the light is reflected differently, but the model is not changed. That's the whole idea about bump map. So this, for instance, is not a bump map. And the question would be, there are more people. Yes, now it's the 4 of us. The question would be, why is this not bump mapping? Because if you look at it from the side, then you see that the pebbles are standing out. And that's not what it does. That's another process which is called displacement. So bump mapping is not displacement. So bump maps do not change the geometry. Here you can actually see a good example of bump mapping. So it seems to stick out, but at the edge you see the edge is still good. The silhouette of a model should remain untouched. And the bump maps are very good for shallow types of roughness, like an orange, a golf ball, brick wall, or something like that. That's the idea. So if you want to have some fun with that and fool around with it, you can take a look at this link in the slides. And there you can see what it actually looks like. And then we can switch to displacement. And more displacement. Where's more displacement? Like me. Oh, here it is. More displacement. That sticks out. Okay. If we don't have the displacement at all, you see that it doesn't stick out. No, it's -1. Oh, it sticks in. Displacement would be 0, then this would be the basic bump map. It's a little bit weird if you fool around with it. Yeah, you can blur stuff out. So that would be a picture. Oh, that's weird. I like it. More blurring. Maybe it gets better. No, it doesn't get any better. A little bit of displacement, maybe. Yeah, looks a little bit better. Put it on a plane. Oh, you can put it on a sphere. And changes the silhouette of it. So that would be the basic idea. Is you can fool around with that, upload your own images, and here we can also remove the need to remove. Very nice demo tool. Okay, so what does the bump mapping come down to? It's actually the normal map. And what you do, as I showed you here, we get in the normal, and I can actually show you the normal too by connecting it here, and it gives us just the, wait, that's stuck. Gives us the direction where the crevice is looking to in relation to the normal of the surface. Oh, I didn't show it to you. Wait. We do it. Amazing. So that'd be this thing, and instead of putting the normal into the normal, we'll put it in the base color. Then you can actually see what the normal map would look like. For this one, that's the normal map. So as you can see, with the straight edges, we only have very small parts here. Now, and as the USR stream boo. I'm repeating the advertisement. It doesn't want me to do. Anyway, Twitch the mystery. We get spammed. 4 people of us get spammed. So the normal map is created automatically from the bump map, and in the lower row you see the created normal map. It's also, of course, an image because we have the 3 coordinates x, y, and z from the normal vector, and we can display it as RGB, and some people can actually read the direction of it. So you can use a normal map, of course, to create these bumps. And bump maps typically can be hand-drawn. That's actually really nice. And normal maps can carry more detailed information than bump maps, of course, because bump maps only have 1 dimension. Well, of course, maps have 3 dimensions. Both do not change the geometry or the shadow or the silhouette. That's the whole idea. And displacement maps, on the other hand, they change the geometry along the normal, and then it changes the whole thing. Then there are alpha and transparency maps, where image data gives the opacity of a point, and you can then make parts of a model invisible or translucent in leaves or dirty glass or something like that. Okay. And how does it look in P5JS? So we have the load image part here, and then we have a texture image. That's what we need in advance. By the way, I looked up the changes to P5JS 2.0, and most of the changes are that everything should be done now in the setup function, and it's an async function. So an image would be await load image, something like that, but it's not a big change. So it should work like that too, but well, maybe we have to add async and await a word here, then it's 2. And in the draw function, we just say that we have the texture in place here, and then we say begin shape. We make a few triangles. In this case, we make triangles. And with these coordinates, we map the texture in texture mode image. 0, 0 would be mapped to this vertex. 0, 640 to 0 would be mapped to this vertex, and so on and so on. With N shape, we have defined the vertices, and we have mapped the vertices to the texture image. And what does it look like? And and S. Oh, I have to find it. And oh, I did close it. And S. 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 Now it logged me out. And S. And S. Great. And S. And S. And S. And S. And S. Here. 7 is the thing texture image. And S. Something like that. And run it. And yeah. And S. And S. Basically an image mapped to triangles. And S. Move it around. And S. And S. And if we mess up this one here, like to be 20, then of course the image isn't mapped so nicely. And S. And S. And S. And S. And S. And S. Back to 0, then it should work again. And S. 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 And so if we want to spread the texture over 3 quads, then we can basically do the same. We're just using triangles here because, you know, P5JS and triangles. That's something. P5JS and quads do not work together very well. I still hope this is be addressed in 2.0 and there. So we can actually have the image on a folder. Nice, is that? So if you ever are wondering what you can do with the panoramic images you can take with your camera, you can actually make a cylinder and put it on the inside, and then you can look around. That's really cool. Sometimes it actually works. I'm not sure when it works and when it doesn't work, but the Google phones typically had this function that you take a lot of photos and then you have these panoramic spheric images. Then you can experience like them, but the last time I checked, it wasn't on my phone. And it dropped the feature at some point. I have no idea. But of course, it doesn't have to be a plane. You can also put it on a folder thing. And S, and S, and S, and S, and S. Yeah, then we have the Earth animation, and S, that, and S, and S, and S. To computer graphics, 07, where's the Earth? Oh, it's down there. And S, sure. And we can just load a texture and then have the Earth rotate in front of us. Also very nice. What does it look like? We have the texture wrap. That's not necessarily needed. And S, and S, and S. We have the texture, we have the rotate thingy, and then a sphere of 150. And with the orbit control, we can move it around, so it's also not needed. Here's the load image, and the image is in there. And S, upload the image to sketch files. And S, and S, and S, and S, and S, and S, and S. And the best of all is the and S, 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 the 4-sided die. So you might know there are not only 6-sided die, but there are also 4-sided die and 12-sided and whatever. And I definitely remove those and add something like orbit control here. And add a little bit better to move it around. And if you keep wondering what sum of the opposite sides is, it's sum of sides, sided die. and there's the mapping. The image would look something like that. And then you basically have to map it. That's the hard part. And there are 2 ways to map the image. And in case of texture mode image, we need to know how big the image is, and we cannot change the image. In texture mode texture, that's pretty cool because you start with 0 and then put in here 1. So 1 would be the full length, 0.5 would be half the length of the image or half the height. And then you can just change the image to a higher resolution if you need that. So that's very much appreciated if you do that, because that would be the method of choice, because then you can do something like level of detail of texture changing and stuff like that. And S, and S, and S, and S, and S, and S, yes. And S, and back to and add collection and the slides and one part is now that you of course have an exercise, and as an exercise you do not need to do something like that, although it would be cool of course. You should create a 6-sided die in P5.js. You can start with Sketch 03, the one with the 4-sided die to take a look at. You can paint or download the texture and then map it correctly. So, and yeah, some of you already did it, at least 9. I think it was more, it was 14 people already did exercise 5. And yeah, give it a try. It's not too bad, but it's actually good to see how awkward this mapping actually is if you do it by hand. If you think it's much easier, no, it's not. For professionals, there are specific programs like Substance Designer and Substance Painter who do the texturing thingy, and it's a lot of work. And I just saw I have this Polyheaven demo. Let's see what it does. And a lot. Okay. Oh, it's a road. Yeah, I think I remember. It's basically a road. And I would have rubble images and on the sidewalk, but you actually don't see it too well. A little bit of the problem. Anyway, I wanted to give you the Polyheaven demo anyway. Just change to Blender again. And the whole idea would be to show you how the actual texturing thingy then works, because it's not just one image, it's typically more images. Okay. And that's what it looks like in a professional way. That's the modeling. That's good. Shading. Let's see what it looks like. And that's what it looks like. I'll just remove this one here. Then we can take a look at the... And as you can see, this looks actually really nice. It looks like a brick ball. And it's quite a lot of different things that work together. So at one thing we have the mapping of the texture, which is in here. You have the texture coordinate and then the mapping, and these vectors are put into different textures. And now just to give you the idea, the base color, that's the base color. So that's the color of the whole thing. We remove it, then of course we'll have no color. Bad. So then we have the roughness. The roughness looks like that. So there are parts that are rougher, parts that are less rough. Remove it, it might be very subtle change. Yeah, it looks a little bit more like plastic. The general roughness, well, here we can put it in. Then we have the displacement. As you can see, the displacement goes into the material output. There's the height to displacement thingy, and the displacement then is mapped to the output. We can scale it. Really weird, but I don't know what it was originally. Set to default value 1. Oh no, 1 is maybe too big. Let's use 0.2. That's also big. Anyway, maybe 0.05, something like that. Looks better. And then we would have the normal map, and the normal map is just here for the lighting. It looks flat in a way because the shading looks different. Oh, that looks much better. So that's how they all play together. It would be of course nice to have this all in one. Of course, this is a problem with definitions, and yeah, you can pack up the materials in Blender, you can pack it up in Substance Painter. There are material definitions and so on, but I'm not aware of any standard that everybody is using, so it's typically depending on your tool chains. Game engine can read that, and your program that the artists use the outputs that, and you use that material design software and that pipeline and that format. So okay, so that's basically it for today. That's about textures. I know it is a very short lecture. I know it's not everything about textures. If there are texture artists that feel like I didn't even say half, yes, you're right. But maybe it gave you a good start on it and lets you understand the complexity of the whole texture. Anyway, I'm talking that much because if questions still arise, then you can put them in. Otherwise, I'll see you in the lecture next week for exercise 8. I think that's the last one that is down to creating stuff programmatically. We'll then move on to the Blender workshop and use Blender. Okay, don't forget about 5th exercise. I think the deadline is coming up. And then, of course, you can finish up until exercise. This was already the last one? Oh my God. Oh yes, exercise 7 is already the last one. Yeah, but the deadline, I think it's still 2 weeks ahead or something. Next week. I think the deadline is for exercise 5. Always a little bit of. Okay, then thank you very much for watching, both of you. And see you maybe later in the board game chat. Bye.